Hello YouTube and welcome to another video. In this one I'm going to be working more on the supercharger project. I have a few more ideas for the intake manifold. Where we left off last time, I said that now that I had the supercharger basically mounted in place, it would be easier for me to figure some things out, and that has been the case. The plate that is bolted to the supercharger right now, to the bottom of it, is 8 inches. And the end plate is going to be made out of this 1/2 inch stock. If I make this plate, the mounting plate onto the engine, 8 3/4, that will give me 1/2 inch on this side, which is the thickness of this plate. And it will give me 1/4 inch on the other side, which is what the plate I'm going to use for that side. Now that I'm looking at it, probably what I will do is make it 8 1/2. And that will actually give me a nice fillet on this side, which is supposedly a nice strong weld. So I'm glad I talked to you guys about this. These sheets here, this one and this one, will be what is used to guide the supercharger air into the engine. And the gap between here, this sheet and this sheet, will create a chamber here and here. And that will be the water jackets where the water flows through. It gets a little bit complicated because I'm going to build a connector between the top and bottom port that goes in between the reed cages, and the outsides of these might actually be folded in to reduce the overall volume of the intake manifold charge area. This one. Nice. I actually have a proper deburring tool. I now need to decide how tall I'm going to cut it. And there's a bit of a problem there because I haven't decided exactly how tall I want it to be. I could go about this in a couple of ways. I just talked about making the bottom of the intake manifold a water jacket. And if I do that, it would be advantageous to have the plate drop a little bit below the studs. But the problem with doing that is that I don't have much clearance over the engine mount bolts. So these engine mount bolts, even without the big thick washers on them, are going to make it difficult to get at the bolts for the manifold. So I've figured out what I'm going to do, and that is think on the fly. I'm not going to make any final decisions. Basically, I'm going to cut the plate so that it comes down to the bottom of the intake manifolds, or the reed cages, and meets up here. I'm going to cut that to size, and then I'm going to fasten it on there. And once I get it fastened on there, my brain will tell me what to do next. This isn't the best way to cut this, but it's accurate enough for what I'm doing. And if I need to, I can touch it up in the mill afterwards. I've got a mill. I figure it would be downright rude not to use it. There's lots of people in this world who don't have mills. We're not nearly as fortunate. So let's make good use of this mill. I've decided that from the bottom of the plate to the center of the bolt holes is going to be 6.5 millimeters. I'm going to mark that out. 6.5 millimeters. 1/4 inch, so 250 thousandths. I know we're switching back and forth from metric to standard, but that's partly because the materials that I'm using are standard and the engine that I'm putting it on is metric, so bear with me. So that line should line up with there. I've now got to figure out where the 6.5 millimeter line on the bottom intersects with the studs. Did I scratch it? I did scratch it. This is going to be a little bit of a guessing game, but it doesn't need to be 100% precise. Because I do have a 1/4 of an inch overhang on each side, if it is a little bit one way or another, all that's going to do is change the way that I weld it, basically. It'll have a little bit less or more of a fillet. It appears as though it does line up. That should allow me to mark my next hole. All right, I've got a good mark there. All right, see how far off there. It actually looks promising. This is working so far. This is probably the shadiest marking that I've ever done, but also the most accurate. I'm now going to give you guys a lesson in units of measurement. Americans use standard, Canadians and the rest of the world use metric, and mechanics pretending to be engineers use eyeballing. About that much is a unit of measurement. I don't have a lot of really fancy tools, but these transfer punches sure do come in really handy. Set them there so that they'll be in my way later, instead of putting them back where they belong. It's kind of tricky to get on. Well, that worked way better than I thought it would. I had mentioned in the other video that I wanted a fillet weld along this side because it's supposed to be the strongest. And now you can see I'm also going to end up with a fillet weld along this edge. Look at that. The next step is done. Now hopefully it will be a little bit easier for me to explain what I'm going to do with the water jacket scenario. I think it's fairly easy to understand on the upper part, but on the lower part, this is what the plan is. So this piece of aluminum is what will guide the air into the engine. I will have a other piece of aluminum that will mount on something like this. This will be a water jacket. As you can see, there are two problems. The first problem is that this nut is inside of the water jacket. Obviously, that's not going to work. And also, the water jacket is touching the motor mount bolt, and that's not going to work. As I'm explaining it to you guys, I figured it out. So I'm going to leave the bottom row of bolts exposed. So when I want to bolt the intake manifold on, the top section will have dowels. 4 dowels that bolt through, but the bottom section will be exposed. So the bottom section will be exposed so that I can get a ratchet in there and get to all of these bolts. However, the water jacket will go like this, so it will attach to that part and then wrap up to here. So it won't go all the way down to the bottom. And then I can feed the water in. At some point, I can feed the water in, the water will go somewhere, and then it will go somewhere else, and then it will go out somewhere. And I made the mistake of trying to figure things out 2 steps ahead, Don't plan stuff, Joel, just do it. All right, instead of playing guessing games at what I don't know, I'm going to start making pieces that I do know. That means I can make the end cover for this, because I know that it's going to come down to here. And I know that the angle of the supercharger is going to be that. And I know that this is going to be that long. That only took 3 minutes. Cool. After just a little bit of touch-up work in the mill. Let's see, that goes like that. Pretty much a perfect fit. This will sit like that and get a fillet weld. Here we go. I got that lined up. I'm going to mark out this cut and this cut. I wonder how well the bandsaw will handle this stuff. Why are you pointing the camera at me? Over here. The work's happening over here. Look. That's better. That's better. Man, it's hard to find a good cameraman these days. I got my pieces all cut out and trimmed up on the mill, all looking pretty. That's gonna sit in there like that, I believe. Now that I've made it this far, I have to do one of the kind of pain in the butt things, which is cutting out these ports. I need to know where they are so that I can design my airflow pieces. I've been playing around with cardboard off camera, and I think I've come up with my final version or final idea for this intake manifold. And I would have liked to have made it so that the air flowed through more efficiently. But for a first-time TIG welder, I think that this is a pretty ambitious project, and I hope that I haven't bitten off more than I can chew. So the water comes in through the bottom here, and as it comes in through the bottom, it goes into this part. This is a water jacket. I'll pull the water jacket off now so you can see where the water is going to come through. And I haven't finalized all of the design, but the water is going to come up through there, and then there's going to be a hole through here into this area. This area will then fill completely with water. Once it fills with water, there's going to be a passage through in each corner here. Drill a hole through it and put it all the way through to there. So the water will flow up to the front. And now if I pull this off, you will see this is where the air actually goes into the engine. And this is the part where the water comes up. The water will also travel up through here and into these water jackets here and here. And then there will be probably an outlet over here or in the back side of the manifold. I might put a 90-degree and have it coming out here. The idea is two things. One, I want to purge all of the air out of it. So if I have the water coming in through the bottom and going out through the top, the whole thing will fill with water instead of getting an airlock in there. And also, when I shut the engine off, all of the water will drain out because this will be the lowest point. And that way I'm not left with water and junk sitting in the manifold all the time. That's pretty much it. These will be cut out, obviously, so the air can come through, and the supercharger will feed in through here. I was hoping to make it a little fancier and make pieces that went from here kind of out, but I think that would be asking for a bit much. I would have to cut out some very, very accurate pieces. As it is, these pieces are going to be fairly tricky to cut anyway, but yeah, this is the plan. Let's hope it works. The main reason why I decided to build a bunch of this stuff out of cardboard is because I started thinking about how I was going to weld everything together, and I started to panic a little bit. I know that this probably isn't a terribly complex process for an experienced welder or fabricator, but I am neither of those things. So I'm going to go through the process of how I plan on welding it together and explain it to you guys, and hopefully if I'm making some huge mistake, you guys will catch it and tell me, but I think I've got it figured out. First things first, the supercharger is going to have to get attached. Whether or not I decide to glue and bolt it in place or weld it in place, that is going to happen first, because once the manifold's welded together, I will not have access to these bolts and I won't be able to weld it on afterwards. Step number 2, these two pieces are actually going to be one piece. So one piece of metal is going to go across like this, or something like this anyway. That'll be one solid piece, and I can weld it here all the way across and all the way across. Once that's welded in, I can cut this hole out, except a lot more accurate, and then a piece of bent plate can get placed in like that. Once the plate is placed in, I can weld along the edges for it and seal it all up. Once that is done, I have a choice of what I can do, but what I will probably do at that point is weld the sides on. So let's see, this goes here. I think these will be welded in place. I can weld them from the outside, from the inside, weld them along the water jackets, make sure they're all sealed in place. That's all fine and dandy. Then I will take the piece here. I will have to cut whatever shape this is into it. That will get placed in there like that. And then that will get welded in place. It'll get welded all along here. It'll get welded along the sides and along the bottom. That's all welded in place. And then I will weld this piece in place, which is not very well represented because it is actually going to have a hole through into there, but it's really hard for me to design that with cardboard. Basically what I'm going to do is use a piece of dowel to go all the way through, and it's going to go through this piece and through that inner piece and have a hole with some holes that go out into the inner chamber. So this will then be put on like that, and this will be welded here and here and here and here. There will be dowels with holes in them that travel through in the corners here as well. So each piece that is put on and fitted will have a dowel that goes through the corner there. And that is that. I hope that wasn't too confusing of an explanation. I put a lot of thought into how I'm going to get some sort of cooling effect out of this manifold. Any sort of forced induction heats up the air, and the weak point of this build, or the weak point of this design, is going to be detonation, dealing with detonation. I don't want to have to run around on race fuel all the time, so I'm going to either have to limit the boost way down or try to cool the intake charge, and I've opted to try to cool the intake charge. I will probably be adding a thicker base gasket to lower the compression a little bit, especially for testing. I'm going to need to get a boost gauge to figure out how much boost I'm actually running, There is a whole lot more left to this project. I have a pretty good idea of what I'm going to do now. So yeah, that's going to do it for this one. Thanks for watching, and I'll see you next time.